everyone, and welcome to lesson 22.4, the final lesson of activity 22 and unit 3, part 2. Today you will need a pencil and a calculator for sure, and that calculator might just be using Google or, of course, your graphing calculator, and you want to double check on both of these that your mode is in degrees, okay? Now, in lesson 22.4, we are going to talk about how we can use the inverse to solve our triangle angles in a right triangle when we are given at least two sides. So we've talked a lot so far about setting up in order to solve and knowing that we can either multiply both sides to get the side length, switch and divide to get the side length that we set up. But then there's this other method that we said we'd talk about in this lesson, which is using the second button on our calculator. And that's involving the inverse trig functions. And what the inverse trig functions do is they work backwards. They use our trig ratios of sine, cosine, and tangent to help us find the angle measures. So you'll see in order to find the angle, we're going to use what we call the inverse, which is like this little -1. It'll show up in your calculator. Okay, so again, it's super important as you look at number 2 that you have the angles in degree mode, or excuse me, your calculator in degree mode. And again, the inverse is to help find the angle in the triangle. Okay, so again, we're looking for angles. So for instance, on your graphing calculator, reason we say second button is you're using, or a smaller calculator, you use second button and then sine. And for part A, they want 1 divided by 2, those in the parentheses. We get an answer of 30 degrees would be our angle measure. Okay. For part B, if we do cosine inverse, so I'll show you how to do that using this calculator here. Again, make sure you are in degrees mode. You want this highlighted. You would use the inverse here. So cosine inverse, or they'll call that arc cosine sometimes on here, of 1/2 is 60 degrees. Okay, so that would be for this one. Another popular calculator you might be using is the decimals calculator. And to make sure that you are doing the inverse on that, again, we are in degrees. And in order to do the inverse on this one, we would need to look at the function key. And for part C, it's tan inverse of 1/2. You get about 26.6. It's going to be an approximation on that one. Try the next couple on your own and see what your degrees come out to be. You should have gotten for sine inverse of 3.4, should have gotten 48.6. Cosine inverse of 3/4 is 41.4 degrees, and then tangent inverse of 3/4, 36.9 degrees. Okay. Now, when we say we are solving a right triangle, that's when we are finding all of the remaining unknown measures. So finding all the missing sides and the missing angles is what we call solving for the whole triangle. Because now between trig and Pythagorean theorem, we should be able to find all of our missing sides and angles as long as we are given at least one side and one angle or two sides. Okay, so notice we have this triangle here, and they want us to focus on using the acute angle of angle Q as our reference triangle. So if we want to find the measure of angle Q, well, we first want to set up looking at this thing. Okay, we have the opposite side and the adjacent side to angle Q. So we know that the trig value that's going to be most helpful to us is actually going to be tangent, because we have the opposite and the adjacent. So the tangent of angle Q is opposite over adjacent. So the difference between this problem and our previous problems is this time we are looking for the angle. We're not given the angle. So in order to do that, that's where the inverse comes into play. We're going to need tan inverse. And we're just going to type in this fraction in order to get that angle measure. So we would say second button tangent of 65 divided by 33. 63.1 would be our answer. Degrees. Because angles are measured in degrees. Now from there are a couple other ways we can find the remaining angles. So if we know angle Q is 63.1 degrees, to find angle R, we can either also use the tangent, but this time this would be our opposite and this would be our adjacent, or we know that 90 plus 63.1 plus angle R has to equal 180. So you could also add these two together and subtract from 180 to get angle R as well. Okay, so it should come out to be 26.9 when we do that. Now to double check with the tangent, if we're looking for angle R, again, the opposite this time would be 33 millimeters. Adjacent is 65. It's opposite of what we had before. And again, tan inverse of 33 over 65 should be that same answer of 63.1. So again, we can practice using the Desmos calculator if we clear all this out. Again, to get here, we had to click function and then tan inverse of 33 divided by 65 is again that 26.9 that we said it was supposed to be. So there's two different ways you were able to get that one. Now, in order to find the hypotenuse, you have a couple different options. Maybe you want to use trig. Maybe you want to use sine, cosine, and tangent. Maybe you're recognizing the fact that that's the hypotenuse and you have the two legs of that triangle. You could use Pythagorean theorem. So 33 squared plus 65 squared, and if we square root that, will give us our answer of about 72.9. Now you'll see that this answer would be the same whether we use Pythagorean theorem or we use trig. For instance, if we again look at angle R, if we're looking for the hypotenuse and we have the adjacent, we could also use cosine of 26.9. We know that that's the adjacent over our hypotenuse. This is a switch and divide problem. So 65 divided by the cosine of 26.9 also gave us that same approximation of 72.9. Okay, so now you have some options of how you're going to solve. Okay, and again, got that same answer. Okay. So again, for number 6, to satisfy what's the minimum amount of information we're going to need? Well, the minimum amount of information that we need is we either need two sides of a right triangle or we need a minimum of one side and one acute angle given in our right triangle. Okay. Otherwise, we don't have enough information to solve. Now, that's not normally going to be the case, but it's something that we need to do. Okay. And then the difference between these last two is that these are inverse operations. If we take sine of 15 in our calculator, what we're going to see is that sine of 15, and if we take the inverse of 0.2558, we get the opposite answers, right? They're inverses of each other. So again, we use inverse to find the angle. We use this to find a side length, just the regular trig ratio. Okay. We will definitely be working more with finding the angles in class as well as the sides using SOHCAHTOA. And congratulations on finishing up activity 22.